Handheld devices allow users to create and consume large amounts of rich multimedia content. And this content includes audio content, like when you listen to music or record voice notes, image content, like when you take and view photos, and video content, like when you take and view movies. In this lesson, we'll talk about the multimedia classes that Android provides, and we'll walk through the APIs and example applications that play audio, that let you watch audio, let you record audio, and finally, that let you use the camera to capture images. So let's get started. Android provides a number of classes and capabilities to support the encoding and decoding of common media formats. Your application can use these to play and record audio, still images, and video. Some of the classes we'll talk about today will be the Audio Manager and Sound Pool classes, which allow applications to play sound effects and audio files and to control a device's audio-related hardware, such as its speakers and wireless headset. We'll talk about the Ringtone Manager and ringtones, and these are the sounds that you often hear when a phone call arrives, when a notification is received, and when alarms go off. And the Media Player, which lets applications play audio and video files. The Media Recorder, which allows applications to record audio and video. And finally, we'll finish up by looking at the Camera class, which lets applications control the hardware cameras on a device. The first class I'll talk about is the Audio Manager. This class manages basic audio capabilities, like manipulating the device's volume, playing system sound effects, and changing the device's ringer mode. Applications acquire a reference to the Audio Manager by calling context.getSystemService, passing in the value context audio_service. And once it has a reference to the Audio Manager, an application can load and then play sound effects, adjust the device's volume, and control device hardware, for instance, by muting the microphone or by turning on the Bluetooth headset. Another related class that can be used to play complex audio is the Sound Pool class. A sound pool represents a collection of audio samples or streams, and the sound pool allows you to mix together and play multiple samples at the same time. Let's take a look at our first example application for this lesson. That application is called Audio Video Audio Manager. And when it runs, this application presents two buttons labeled up and down that are used to increase and decrease the device's volume. The application also displays a button labeled play that, when pressed, plays a bubble popping sound at the current volume level. Let's run the application now. So here's my device. And now I'll start up the Audio Video Audio Manager application. And as promised, it displays three buttons: up, down, and play. The application also shows the current volume level on a scale from 0 to 10. Right now, the volume level is set to 6. Let me press the play button so you can hear the bubble popping sound. Here goes. And now I'll press the up button a few times to go to maximum volume. And now I'll press the play button again. Now I'll press the down button and play button a few times, and you should hear the bubble pop at increasingly lower volumes. Here goes. Let's look at the source code for this application. Here's the Audio Video Audio Manager application open in the IDE. Now I'll open the main activity. Here, the onCreate method gets a reference to the Audio Manager. Next, it begins to set up its user interface. First, there's the text view for displaying the current volume level. Next, there's the Up button. And when clicked, this code plays a key clicking sound and then tries to increase the volume level and update the level display. Next, we see the Down button. And this is almost the same as the code for the Up button, but it decreases rather than increases the volume level. Next, the code gets a reference to the Play button and then disables the button for now. After that, the code creates a sound pool object, which it will use to play the bubble popping sound. The parameters for this sound pool object indicate that it will have only one audio stream and that the stream is played on the audio music stream. Next, the code loads the bubble pop sound. Loading the sound is an asynchronous operation, so the code sets an onLoadComplete listener, which will be called when the sound is finally loaded. And when the onLoadComplete method is called, the code checks whether the operation was successful, and if so, it enables the Play button. Earlier, the code disabled the Play button, and it did it to make sure that it didn't try to play the sound until the sound was properly loaded. Next, the code sets a listener on the Play button. When pressed, this code plays the bubble popping sound at the current volume level. And after that, the code requests audio focus, which means that it essentially wants to be in charge of the audio being played by the device. There's also some code in the onResume and onPause methods. The onResume method turns on the device's speakerphone and then loads the system's sound effects, like the key click sound effect that we used above. The onPause method begins by unloading the sound pool and releasing its resources. And then it turns off the device's speakerphone and unloads the system sound effects. The next classes we'll talk about are Ringtone and the Ringtone Manager. The Ringtone Manager provides access to the audio clips that you hear, for example, when a phone call arrives, when you receive a new email message, or when an alarm goes off. And through the Ringtone Manager, applications can get and set various ringtones, and they can play and stop playing them. Let's see an example application that uses the Ringtone Manager. Now, this application is called Audio Video Ringtone Manager. And this application presents 3 buttons respectively labeled Ringtone, Notification, and Alarm. Pressing one of these buttons causes the associated default ringtone to play. Let's give it a try. Now I'll start up the Audio Video Ringtone Manager application. As you can see, it displays the 3 buttons, Ringtone, Notification, and Alarm. Let me press some of these buttons. First, let's listen to the default ringtone as I press the Ringtone button. Now, let's try the default notification ringtone. And finally, let's try the default alarm ringtone. After this segment is over, try downloading, installing, and running this application on your device. And then go to your Settings application and change your default ringtones. When you then rerun this application, you should see that it plays your new ringtones, not your old ones. So let's look at the source code for this application. Here's the Audio Video Ringtone Manager application open in the IDE. Now I'll open the main activity. In the onCreate method, the code creates 3 buttons. Let's look at the ringtone button as an example. Now here, we see that when this button is clicked, the code uses the ringtone manager to get the URI for the default phone ringer ringtone. Next, the code gets the ringtone associated with that URI by calling the ringtone manager.getRingtone method, passing in the URI. The result of all this is then passed into a method called playRingtone. Let's scroll down to that method. Now this method checks to see whether the ringtone is currently playing. And if one is, then that ringtone is stopped by calling the ringtone class's stop method. The current ringtone is then set in the mCurrentRingtone variable. And if the current ringtone is not null, then the code will start playing it.